Buenos dias. This presentation is a presentation for a paper at the European Conference on Modeling Foundations and Applications. The title of the paper is Model Finding in the EMF Ecosystem. The authors of the paper, you find them over here. The paper is a Spanish-German co-production. The context of our work is the Eclipse modeling framework and model finding. The EMF framework is the main currently applied meta modeling framework. It has a rich ecosystem of plugins and tools. EMF offers options for enriching meta models with OCL constraints. However, EMF currently lacks usable model finding approaches. A model finder searches for models satisfying particular formulas, for example, OCL constraints. Model finding is applicable for several tasks in software development, for example, for model verification or model synthesis. We have used here a robust model finder from the UML-based specification environment use with a reference over here. The contribution of this paper is, as said, we are offering a model finder for EMF. It is designed for scenarios like model consistency, example generation, or partial solution completion. We offer several OCL variants that can be processed. The approach is realized in a tool with a reference over here. The usability has been proven by implementing 3 different application scenarios. We have evaluated the capabilities of the model finder by analyzing OCL constraints from an OCL dataset with several hundred EMF OCL models. And our model finder is able to process about 65% of the considered EMF OCL models. So what is model finding? The basic idea of model finding is that you have a class model, say a UML or EMF model as shown over here, where parts of the relational data model are described. The model includes OCL invariants, and model finding is basically the process in finding an object diagram that on the one hand respects the structural requirement from the class diagram, and the object diagram has to satisfy also the OCL invariants that are also stated for the UML model. The tool architecture, we see it over here. The tool supports several OCL variants. These are mapped into an intermediate OCL representation. A static analysis is done, and then a typed OCL representation is achieved. The OCL invariants go together with an EMF meta model. This is adapted and sliced for the use in the tool that we apply, the tool use. So finally we achieve a class model and OCL constraints that can be processed by the model finder, the MV, the model validator in this tool, together with a so-called configuration that describes additional information Object models are produced by the model finder, and these object models are transformed into the EMF format, and then these object models are presented to the developer. So the developer solely works on the EMF level. The developer is not concerned with the internal details here of the use model. Another functionality that we have realized is we can also specify partial EMF models, and these partial models are then completed by the model finder and are also returned in EMF format to the developer. Concerning the evaluation that we have performed, we were interested in evaluating the ability of the tool eFinder to process real-world OCL expressions. To achieve this, we have used an external OCL dataset. The dataset consists of around 500 files, of which 300 are valid OCL files, which contain more than 2,000 constraints, and we have fed eFinder with these files, obtaining the following results. eFinder was able to verify 64% of these files. If you process the constraints individually to avoid the effect of a single unprocessable constraint that spoils the whole file, then eFinder is able to process 76% of them. There is a percentage of constraints that cannot be processed by eFinder, either because they include features which are currently not supported by eFinder, like sequences or some string operations, or because eFinder can currently not reliably work with the file. Nevertheless, altogether, we believe that this evaluation shows that eFinder is already a useful tool to deal with non-toy OCL models. We have presented eFinder, a framework for model finding in the EMF ecosystem. Our tool supports several OCL invariants. We have done an evaluation. We have processed about 65% of the OCL that is present in a third-party OCL dataset. As future work, we want to enhance our support in the use system. So-called classifying terms are available. Classifying terms give an opportunity to do systematical tests, and we want to lift this feature from the use tool to the eFinder tool. We want to handle OCL operations that are not supported yet, in particular string operations, and we want to perform some practical larger case studies in the EMF context to learn more about the applicability of the tool eFinder. Thanks for your attention.